Let's look at another cute thing that happens with the desert mechanism in the neighborhood of the monsoon. We looked at this profile before, talked about how the daytime physical processes happen over the thermal low. There is a sensible heating and radiative cooling balancing each other in the lower part. There is radiative and sensible heating in balance, so this sensible heating is taken up by the rising air, creating this divergence. So there's a convergence below, divergence above, as we talked about, and then there is radiative cooling and radiative cooling balancing adiabatic and subsidence heating over here. So basically, when you have no water vapor or no water available for all this heating to be lost in terms of evaporative cooling, you can end up warming the surfaces quite rapidly by radiative heating. So you end up with really hot temperatures and low pressures that are called the heat low. Okay, these can create some unique situations as well, and this is showing one of those. So this is called a subsiding lateral exhaust. So essentially that heat, the heat low that's getting created over the Saudi Arabian region here is going to get lost laterally into this Western Arabian Sea. So even though it's air originating on the desert, it ends up actually modifying the moisture, the cloudiness, and so on here that actually affects the monsoon as well. Okay, so this is showing the schematic of the impact of the outflow of the Arabian heat low, which is this brown arrows here. Smith et al. Referred to outflow as the desert lateral exhaust that occurs over the summer monsoon boundary layer flow. These are the bold blue arrows here, southwesterly flow that we all very well know about the monsoon circulation. The mean JJA isoheights or the rainfall contours are shown here. So you can see the Western Ghats rain and Bay of Bengal rain and the core monsoon rain and so on. Below the desert outflow region, there is a minimum of rainfall. So obviously, once you get into this Somali upwelling region and the desert, there is no rainfall here. The isentropic analysis, according to this paper, along this line B prime here and A prime here, shows that this flow is basically largely adiabatic. So it's flowing down isentropes, as you can see here. The A prime is cutting across the southwesterly jet, so you can see the impact, and you can see this desert outflow in this pressure longitude section, that the flow remains essentially isentropic. So it's adiabatic, and also along B prime, which is cutting across in this direction, again largely isentropic. Okay, so this has a huge impact in terms of creating cloudiness here and trapping moisture, and in fact reducing rainfall, so that you have more of the moisture going in this direction. If it rains over here, obviously you're going to lose some of the moisture, whereas this dry hot air that's actually laterally exhausting into this monsoon dynamic region is actually modifying the Western Arabian Sea and making it drier and enhancing the moisture supply into the monsoon zone. So it's kind of interesting that the desert dynamics and the heating, because it's a desert, actually ends up modifying the monsoon dynamics. We'll look at the other interaction between the deserts and the monsoons in terms of how the monsoon heating itself will affect the desert. Remember, again, we said deserts are approximately in the downwelling branch of the Hadley cell. Then we said that the maximum subsidence actually happens in December, in the winter months, and not in the summer rainy months. So where is the additional subsidence coming from? The idea was proposed by Rodwell and Hoskins, which argues about Rossby waves forced by this heating. You remember our wave dynamics where we said diabatic heating can set off waves, which is what a lot of the discussion was about, how tropics can affect the extratropics by generating divergent flow in the upper atmosphere. And we also looked at the monsoonal heating situation where we talked about how potential vorticity substance is affected by monsoonal heating and the tropical extratropical interactions. So we will look at those. So this is another interesting aspect of the desert mechanism, the lateral exhaust related to the Arabian heat low.